land that we need. And when we're talking about biogeochemistry, we're talking about the cycling of these nutrients between the living compartment and the non-living compartment. And so within a stream, you can think of nutrients being in the water column and they're moving downstream. They can be entrained on a particulate, and a filter feeding mussel or some other filter feeder can take it up, use it for growth and reproduction, and then they excrete it back out. So, all these organisms out there are transferring these nutrients from non-living back into themselves and then also excreting them back out into a non-living form that can be used by other organisms such as algae. And so within a stream ecosystem, primary producers, as in terrestrial systems, are fueled by light, but also structured by the availability of nutrients. And this is going to influence the entire food web. And within aquatic systems too, you also have leaf fall entering this. But we're going to mainly focus on nutrients and primary producers and how animals influence this cycling. So when we think about nutrients and nutrient limitation, there's a law called Liebig's Law of the Minimum. And it states that primary production is limited by the scarcest element within the environment. So if there's a ton of nitrogen out there, but not much phosphorus, algae is not going to be able to grow unless they can get some phosphorus. Because if they don't have enough phosphorus, they're not going to be able to complete. And so the limiting nutrient is going to be the nutrient that supply to demand is the lowest. And so this impacts algal growth, community composition, and a plethora of other things within all ecosystems. And in 1958, Redfield went all across the world and sampled algae in the ocean. And he found that algae, this carbon to nitrogen to phosphorus ratio, is often 106 to 16 to 1. So that's the ratio of nutrients that need to be available in the environment for the algae to do well. And it's been said that if the N to P, the nitrogen to phosphorus ratio, is less than 10, nitrogen is scarce relative to phosphorus. And if it's N to P is greater than 20, phosphorus is scarce relative to nitrogen. And if it's somewhere in the middle, there's some sort of co-limitation going on. So both nutrients are limiting at different points in time. And all of this has evolved into what is known as stoichiometric theory. So there's this nice book called Ecological Stoichiometry. I highly recommend it, especially if you're interested in this kind of thing. And it uses these elemental ratios